So, ladies and gentlemen, you are welcome to our video. So, in this video, we are going to look at the next question, which is question 5. So, the question says, determine the rate law from the table, which shows that the concentration of the reactant A in unit of molar and the initial rates of the reaction in unit of in the unit of molar per minute. So we are given two experiment 1 and 2, and of course that the reactant is A. And of course, so the first thing that we are going to do is to drive the rate law of the reaction. So it means that in this case, you have A as the reactant, which actually gives us our product. So to get the rates of this reaction, so the rate is going to be K into A. So we don't know the rate of the order of the reaction, so we can just make it X, which is unknown. So it is unknown. So we have two set of experiments. So we have experiment 1 and 2. So in the experiment 1, we have the initial concentration of A and the initial rate. So how are we going to do it? So you can now say for the experiment 1, we have of course we have the concentration to be we have the concentration to be of course we have the concentration to be 0.2 and then the rate 0.4. So let's say for the first experiment, let's say this is our first experiment. So for our first experiment, we have our initial rate to be 0.4. And then of course, so initial rate is 0.4 is equal to K, which is unknown, then into the concentration. So the concentration of A in the first experiment is 0.2. So we have 0.2, then we close the bracket, then we have our X. And then the next one is the second experiment. So we take for the second experiment. Then for the second experiment, we have the initial rate to be 1.6, then into K, and then the concentration is 0.4. So we have 0.4. Then we close the bracket, then power X. So the most simplest way to get this, we can just say, okay, we can divide equation 2 by 1. So to do that, then we can just simply set equation 1. So the equation 2 is having the rate is 1.6, then is equal to K into, of course, 0.4. Then we now close the bracket, then we have our X. Then for the equation 2, or for the experiment 2, we have, of course, 0.4. We have 0.4 is equal to K, and of course into, we have 0.2 here. And we close the bracket for our X. So then the next thing, the K here, of course, will now cancel the K here. Then we have 1.6 divided by 0.4. So if we have 1.6 divided by 0.4, what are we going to have? So therefore, this implies that when you now take 1.6 divided by 0.4, it's going to give us 2. And then, of course, we have this 0.4 divided by 0.2. So if you now take 0.4, of course, here we have 1x and we have, sorry, here we have x and here we have x. So we can just simply say that we have 0.4 divided by 0.2, which of course it is going to give us 2. So it is going to give us 2. So of course, as I said, we have 1.6 divided by 0.4. So 1.6 divided by 0.4, of course, what it gives us is not 2. So here, what we have is 2. We have 2 here. So what we have here is 4. We have 4. And then when you now take this 0.4 divided by 0.2, it is going to give us 2. So here we have x and here we have x. And remember, according to the rule of indices, then you can just take 1x. So now we have 4 and then we have equals to 2 power x. So what are we going to do? I think it's simple to equate the index, which implies that 4 is the same thing as 2 power 2. And then we have 2 power x. Then the 2 here will now cancel these 2. Then we now have x is equal to 2. So it means that the order of this reaction is 2. So the correct way of writing this equation is by saying that rate is equal to k into concentration of A raised to the power of x. So now it becomes k here. It's now become, of course, it's now become, we are now going to substitute the value. So it now become, of course, k, now become k into the concentration of A in brackets, and then now close the bracket, and of course the x is 2. The x is 2. So therefore, what is the answer here? So we have to look at the option that suits our answer. So it means that the answer here is A. The answer is A. So ladies and gentlemen, thank you very much for watching this video. And if this is the first time you are coming to my YouTube channel, please subscribe. And okay, so you are all welcome. So please subscribe.